Oh, greetings, one and all. Let's get this show on the road, shall we? But we're going to kick things off and welcome for everyone who's dialed in already. Welcome to my esteemed colleague and director, Ocean Protect extraordinaire, Michael Kenneth Wicks. How are you, Michael?
Good, Brad. How are you?
Oh, just living
Doing
the dream
well.
and keeping it real, and I know we've got another one of our esteemed colleagues, Daniel Ryder, hanging in the bleachers, going to help us with any sort of technical support that we might need to keep us in line. But look, before we get too far ahead of ourselves, I'll give people an opportunity to come through the virtual turnstiles. And thanks for everyone who's dialed in today. I think we've got about 180 registrations at last count, which is great because we only announced this a little while ago, and I know it's a busy time of year. But a quick plug for a couple of ocean protective related things before we kick off proceedings. Look, if you haven't seen it already, the webinar series for next year, the Stormwater Fundamentals series, is back again. Super popular in 2024, but because of all the awesome feedback and people just keep turning up in their droves, we're going to do it again. So a whole bunch of people from various groups, Optimal Stormwater, Quality Engineering Group. I'm sure Sean's probably dialing into this one. E-Water are going to kick things off on session one, and they're all free on a lunchtime on a Wednesday throughout the year. If you miss it, you can watch the recording later. And obviously, it's CPD as well. So if you're keen to dial in to any or all of those events, just jump on that website. You can see there, and or subscribe to the newsletter so you don't miss them. Um, Also, a shameless plug, the podcast keeps on trucking, sixth season. Our last episode will be released on Monday, which is a doozy. So if you're not already a huge fan, and look, who isn't? I don't know about anyone. I'm sure
I've
they're out
heard
there.
some bad reports about the host though, Brad. I heard he's a bit
Yeah, true.
average, and we could probably change that out next year. I think at Ocean Protect,
Look, I
but
wouldn't, look, hey, I do not have the monopoly of that. I'm sure Daniel will do a fine job, as you would, uh, until you probably crash and burn, say something silly, So. The pressure, Michael, of being a podcast host, it's a heavy burden. So. No,
I know
it's great
nothing. I
fun.
know nothing about pressure, Brad. No.
But look, it's available on iTunes and Spotify. 180 episodes deep so far. So for your listening pleasure, something to listen to over the Christmas holidays. Uh, and just a reminder, and we always get people asking this. If you do have any questions, please put them in the Q&A panel. But also a reminder, the slides and the recording will be made available very soon after today, in case you miss it under that website just there, along with all the slides and recordings for all our webinars. And if you are after CPD requests, if you're after a CPD form, please email them to inquiries@oceanprotect.com.au. I'll have that email up again at the end, just as another reminder. But yeah, if you do want your CPD, please email that email address. So let's get this show on the road, shall we?
Let's kick it off,
So
Brad. It's this journey started in what 2012, talking about SQIDEP, and so let's get on with this. 2024. Let's move.
Right, yeah. So, and for people who, this is the rough agenda for today. I'm going to talk about what SQIDEP is, etc. Where is it applied? Overview of the Filterra bioretention technology or system that we're talking about today. I'm going to give you a bit of a deep dive of the study that was actually used in the submission of the for Filterra for SQIDEP, the one that was reviewed by the reviewers, and also give some insight as to, I guess, what the SQIDEP experience was like, and also give you an idea of what are we doing next, and some Q&A as well. So for those who don't know what SQIDEP is, lucky you. But it is an acronym. We do love our acronyms in this industry. But it is a stormwater quality improvement device evaluation protocol. It's basically just a protocol or a procedure that's managed by Stormwater Australia to essentially evaluate the performance claims of stormwater quality improvement device manufacturers like Ocean Protect. And it's a whole bunch of informations on that website as well if you're keen to find out more. Where is it applied? And I think historically it was envisaged that this would be like a national protocol that would be applied everywhere. To date, at least, that certainly hasn't come to fruition for a bunch of reasons. But fundamentally, it's predominantly a Southeast Queensland thing. So if you want to put in proprietary stormwater quality improvement devices on a couple of areas, particularly Gold Coast and Ipswich and Sunshine Coast, you must have a SQIDEP verification. In Logan and Moreton Bay, you don't have to have it, but they do sort of have at least indicated that they accept the performance values that SQIDEP have verified. Brisbane City Council are in a similar boat. They have indicated that they're going to move eventually to a mandatory SQIDEP requirement for all devices, but they've extended that requirement out several times already. So who knows what they're going to do next? But fundamentally, yeah, certainly there's at least 3 councils in Queensland that if you want to put squids in, you have to have SQIDEP verification. In New South Wales, there's Aerotropolis in Western Sydney that you do need a SQIDEP verification. And Blacktown City Council do refer to SQIDEP as a requirement for new squids in their WSID developer handbook. But there's also some additional requirements that they put on proprietary devices. And to the best of my knowledge, in Victoria and South Australia and Tasmania and WA, ACT, and NT, I don't really see SQIDEP getting much of a mention, but I could be wrong. So I'll give a quick overview of what Filterra bioretention is now, just to give some context as to the study that was then submitted to the SQIDEP review. So if you're not familiar with Filterra, that's cool. It's basically just like bioretention, so conventional bioretention, but with a bunch of key differences that I believe add to the resilience of these systems, but also their performance as well. Two really key things. So first up, so this gives you a conceptual diagram of I guess the 2 types of configurations generally, the bioscapes or biobase on the left and the tree pit configurations on the right-hand side. Key differences you can see straight off the bat is the filter media is different. So instead of using sandy loam media, which might drain at 200 millimeters an hour roughly, we use what we call Filterra. That's the manufactured filter media made in Western Sydney, and that drains much quicker. That drains about 3.5 to 4.5 meters an hour. And that key reason is why Filterra bioretention systems are smaller. Generally, as a rule of thumb, they're generally between 3 to 5 times smaller than your conventional bioretention system. Hence why they're particularly attractive to constrained sites and similar. But in my experience, most urban developments is quite constrained. Another key difference is mulch. And then we're seeing actually this is being recommended as for conventional systems, which I think is a really good thing. But fundamentally, we've been doing this for a long time now. So we put a 3-inch layer of mulch on the surface of the Filterra media. Why? It does 2 things. It acts as a GPT, basically, to help screen silts and fines that can otherwise block filter media. Another thing it does, it helps to retain moisture within the filter media. It's just like mulch on your garden bed. It helps to keep water within the soil, which is obviously great for plants to grow in. A couple other key differences. You can see we don't have a transition layer. We don't need one. And generally, they're shallower systems, the Filterra bioretention relative to conventional, in addition to being so much smaller. For the bigger systems, to minimize any risk of scour and erosion, we keep them offline. So water basically will build up in some sort of forebay or pit, and then basically bubble up via a bubble up arrangement, or a trough system. And that does 2 really good things. It really helps to distribute flow across the mulch or filter media surface. It obviously minimizes any scour and erosion. Also makes it really easy to build. Minimize construction, laden runoff, etc. And also means these systems actually are generally a little bit higher. We can make them higher. A key challenge we see with conventional systems is just getting the systems to drain. Generally, you've got water going onto the surface from a pipe, and then you've got a depth of media and mulch and gravel, etc. And then you've got to discharge the under drainage. We generally see Filterra bioretention systems can be roughly, as a rule of thumb, about 0.5 meter higher. Which again makes them a lot easier to integrate. I talk about the filter media. That is the key difference. That is the only proprietary component of the filter media. Everything else, pipes, mulch, plants, etc., you can readily get from others. And you should never need to get Ocean Protect involved in the project after we've established the system. But as part of any installation that we do, we essentially take full responsibility of the system. So our team will design it, our crews will install it, and then as part of any installation, we look after it for a year as part of the deal. So if something goes wrong, it's on us to fix it up, which for me is a huge advantage to what we do. And I think that should be the case for conventional systems as well.
Yeah, look, absolutely. And I think that the key the key difference with Filterra not only is the high flow and the great
Mm,
performance, but we've designed every layer in this bed, whether it be the mulch, the media, and also the stone, to work in unison with the other layers. We don't just grab a speck for stone and, oh, that
mm,
will drain and that's great. We the three layers need to coexist together to get the most out of it. That's why we don't need things like transition layers. That's why we don't have to put irrigation in. If you put careful thought and process into each layer, and we don't just spec it and that's it, but we spec it, we QA, we QC, we manufacture, then we install it all as sort of one as a system. And that's why we're seeing, I suppose, more successful outcomes with Filterra than any other bioretention system
mm.
on the planet, really.
And I'll show some results to that effect in a sec. But in terms of application, just like conventional bio, whether it's at source or end of pipe, we've done a lot of them now. We've installed well over 180 in Australia alone. In the States, this is not a new technology. It's been around for about 20 years. This is one of our earlier systems installed in 2017. So what's that, 6 or 7 years old now? Hasn't really got much in the way of maintenance. I think the mulch has been removed and replaced maybe once or twice. But you can see here a real diversity of vegetation. So generally recommended trees with understory vegetation to provide a whole bunch of other benefits as well. This is one of our bigger ones out at Silverdale. There's a couple that have been in the ground for about 6 years now, and there's actually two that have just been built, similar size. I think one's about 530, the other one's about 290 square meters. I think the other two are around about similar size or smaller. And this is, and it kind of shows some features around, this channel you can see here. It's a high flow bypass, so the high flows don't scour the system. This is another system out at Ingleburn. Long story short, we've done lots of these now, but visually, it looks just like conventional bio. Very similar planting palette. Ideally, you walk past these and don't notice it's there, basically. It should integrate seamlessly into the urban environment and provide other, amenity, ecological, urban cooling, etc. benefits. Ones like this, we're actually being asked to remove conventional bioretention systems that have not met their original design intent and replace it with Filterra, albeit just smaller. So that, like this one that we did for Kingston City Council in Victoria. But in terms of the configuration, yeah, there's pits and pipes and like raised boxes as well, as you saw in the case studies. Maintenance is really simple, and I think this is a key reason why a lot of councils are actually preferring them as public assets relative to conventional systems, is the ease of maintenance. There's a lot of ways that bioretention systems can fail, and there's a whole bunch of things that we do to prevent or at least minimize that chance. But the maintenance activities can be done by pretty much anyone that's suitably qualified. The key thing is we just recommend replacing that mulch. We generally say somewhere between, it's probably getting updated every day the more we find out about Filterra, but it's generally about a 1 to 2 years is the maintenance, is the mulch replacement frequency. In addition to the mulch being replaced, say every 1 or 2 years, it's just trimming the vegetation back a little bit. So no specialized equipment. You don't need OSHA Protect to do it. You can probably get a bush regeneration team to do it, etc. And look, like I said, we've done a lot of these already. How to specify them? Very simple. You can just get OSHA Protect to help you with the music modeling or do it for you and do design drawings, etc. Generally, what we're getting is just a blob on a page, which is fine, and we can work with that. But if you're in doubt, just give us a shout. But that's a very quick crash course in what Filterra bioretention systems are. I'm going to talk about the study now, that we actually submitted as part of the SQIDEP review. First up, the methodology. Long story short, you've got to find a site that's actually suitable to test for. So we started with 12 sites and did a whole bunch of baseline monitoring and assessments, whittled it down to eventually one. That site being out at Kingswood in Western Sydney. The other thing you need to do is develop what we call a quality assurance project plan. Basically outlines how you're going to do the monitoring, sets the rules and requirements and procedures before you actually start implementing them. So what's the qualifying storm? What's the non-qualifying storm? What's the chain of custody, etc.? Who does the analyses? How's it done, etc.? It basically provides a very robust framework to do this monitoring before it actually is undertaken. So everyone's on the same page. One of the dramas that we had for the study site out at Western Sydney was SQIDEP was just new. We also had the Gold Coast City Council had their own squid protocol, and also obviously TAPE in the US. They all had their different requirements or different rules and procedures. So fundamentally, we just applied a QAPP that is complies with all of those existing protocols. Keep in mind, we actually started monitoring on this site in 2018, so we've been monitoring for 6 years now. But in that time, Gold Coast have made their protocol redundant. And obviously, SQUIDEP's a little bit more, I guess, well known particularly in southeast Queensland. So, but why wouldn't we just use SQUIDEP? Well, fundamentally, it was early days of SQUIDEP. And still now, it actually isn't endorsed by a bunch of key stakeholders. So if you look on the websites of Stormwater Victoria, Stormwater New South Wales, Stormwater Queensland, they all provide advice around the application of SQUIDEP, and they've also provided their public submissions to Stormwater Australia on SQUIDEP. But fundamentally, none of those groups endorse SQUIDEP in its current form, and they're all asking for improvements or changes. Similarly, other regulators like Melbourne Water and a bunch of other governments do not endorse SQUIDEP. So we obviously want a robust procedure before we actually do it, before we actually go ahead and spend the money of actually undertaking this monitoring. So long story
Yeah,
short, we just applied all of the rules and requirements that we could see. Michael.
yeah, and that was an issue for us. Like we've been talking about these issues and technical deficiencies and problems in process since 2017 when we saw a draft. And but at the end of the day, it's the only national protocol that we've got. So
Mm.
whilst there is issues, whilst there's problems, whilst it's not perfect, that's the only thing we can really follow. Now, with the local governments starting to endorse it, well, then we had no choice.
Mm.
So we were more or less forced to go down this path. Yeah, as I said, it's not perfect, but it is what it is, and it's the only one we've got. I think the key now is to make it better. Um, we need some changes now. We're 5 years after the release, coming up to the anniversary, and we need to start looking at these fundamental changes before we even look at lab testing, because lab testing will never take the place of field testing and never can. We need to look at some changes to the program and also to the technical standards so we can move forward for the next 5 years.
Cool. In terms of the site location, I've already mentioned it's actually in Western Sydney. There, the climate statistics you can see. 720 millimeters average annual rainfall in the car park of essentially the Western Sydney University campus at Kingswood. It's a 420 square metre catchment. It drains to a tree pit system, 1.2 metre by 1.2 metre Filterra tree pit system, which is 0.3% of the upstream catchment. Maintenance was typical, nothing fancy. And like I said, we've been monitoring that since 2018, and we still are. This is just shows some happy snaps of the installation of the system back in the day. You can see that essentially is the Filterra bioretention. So stormwater will basically drain into it via a cutout in the curb. Any flows that are a little bit too high will spill over into this overflow pit. And this cabinet you can see here has a whole bunch of very, very fancy monitoring equipment. The technical expertise within Ocean Protect is incredible. I'm very comfortable saying I'm definitely one of the least smart guys in the room when I sit in a room with my R&D team. So they're very smart, and it can all be done remotely. So we can program the sample collection, etc., all based on climate forecasts, etc. Because it's very difficult to sample stormwater. Can't be just done by grab samples. We need auto samplers. There's a whole bunch of technical know-how that goes into doing that properly, as we've seen, and we've been doing that for a long time now. So kudos to the R&D team involved. But yeah, there's just more happy snaps of the system. There's some happy snaps of the setup as well. So fundamentally, we're measuring flow, we're measuring rainfall. It's automated sampling, so taking samples of the inlet and outlet. And all for the study set or group of data that we submitted to SQUIDEP for review, all of those samples were collected and analysed by ALS. So fundamentally, Ocean Protect didn't have any hands on any of the samples at all. So we were involved in obviously the initial setup and the occasional maintenance. I think we removed the mulch every year or two. But apart from that, all the sample collection and analysis was obviously done by an independent NATO accredited lab.
And that's the key. So because we've been doing this since, sort of 2005, we don't have to touch the site. So we can control it completely remotely. And that's from setting up the samplers to run based on forecasts. We have algorithms to run that in the background. We have a central dashboard that we program all our sites, because this is just one of many sites that we have that we're field monitoring. So we run diagnostics before the storm. So we have literally up to the minute forecast data coming in. We have an algorithm programming the pacing for the storm, setting up for the size of the storm, that communicating with all the samplers and all the different sites. And then when the storm actually rains, we get a notification, text message, and email. And then from there, we know when the storm ends. So we can send that data straight to ALS and say, hey guys, this hydrographics at Penrith in this case, hey guys, can you go out and collect the samples? So we actually do not touch any of the samples whatsoever. So it's complete third party chain of custody of sampling. They collect the samples, they split, they put in the bottles, they send it to the lab, they analyze, they do all that. So yeah, we can, even though yes, it is our site, we can basically not be on site and not touch any of the samples. So it's a really sort of unique and a very fundamental important path, because even if we were a consultant, we shouldn't be touching the sample bottles. It's at the end of the day, that needs to be done by someone else who's completely independent from the manufacturer.
Cool. Fundamentally, the qualifying events that were all collected and analysed by ALS that were submitted were it was basically a 12 to 13-month period. We collected 16 events, so you need 15 as a minimum for SQIDEP. And the rainfall events were highly variable. The big ones, little ones, etc. And we had 5 events that certainly indicated that the system was operating at probably full or at least nearing capacity, or certainly above what we call the treatment flow rate. So as a rule of thumb, the saturated hydraulic conductivity of Filterra is 3.5 meters an hour. It's obviously higher than sandy loam, hence we can make these systems smaller. When it's got a driving head, that obviously increases, the drainage rate will increase, but we certainly had 5 events where the flow rates were above 5 meters an hour. So certainly the treatment flow rate was exceeded for 5 out of the 16 events. What do the results show? So this is the results from that set of data, and you can see here I've broken it up into total suspended solids, dissolved phosphorus, total phosphorus, NOx, ammonia, nitrogen, dissolved inorganic nitrogen, total ketol nitrogen, total nitrogen. What people are generally more concerned about is the comparison against the load removal targets, TSS, TP, and TN, depending on where you are in the country. They are generally around about 80% for TSS or thereabouts, or 85, 60 or 45 for TP, and TN's generally around 45%. But fundamentally, this small, Filterra bioretention system size at 0.3% of the upstream catchment overwhelmingly exceeded those load removal targets, and obviously observed high load removal rates. And that's pretty consistent what we've seen in other studies as well. And I'll talk to that in a little bit as well. In terms of, whilst the SQIDEP verification is really good, it's worth noting that this is one of about 7 real-world published studies on the performance of Filterra bioretention systems. In addition to the SQIDEP reviewers that Stormwater Australia employed, this study site has already been reviewed by 2 others, Dame McCann and Ralph Filidro, who were basically asked, hey, does this comply with SQIDEP? Yes, it does. How would you model it in music using a bioretention node with adjusted properties? So long story short, the SQIDEP verification that's come out of Stormwater Australia is very consistent with what we've seen in other peer reviews. And those peer reviews are publicly available, as is the SQIDEP verification or SQIDEP reviewers report. If you jump on our website under Filterra, you'll see a reviewed paper and all those peer review reports, plus all the published studies are all available in that document as well. So yeah, the key point I want to make here is this isn't just a SQIDEP verification one study. This is one of many studies of Filterra bioretention system in Australia and US that have demonstrated really high rates of pollution removal. as per this table. So this basically shows how the current study compares in terms of efficiency ratio, which is the concentration removal metric, or one of them at least. You can see basically the results that we saw in the SQIDEP study, or the current study, are very, very similar to what we've seen in other studies. And this study site itself, a study paper has already been published on this in the AY Water Journal, written by myself and Michael and a couple others. And again, even though it was a few years earlier, it still showed really, really high rates of pollution removal. But again, it's very consistent with what we've seen in other studies in the US. And I think there's a real key reason for that consistency. And it particularly comes down to the point that Michael made before around how careful, how thorough the process is when it comes to designing, installing Filterra bioretention systems, particularly in relation to the filter media. There's roughly a 25 QA/QC step to make sure that the filter media is in accordance with the appropriate specification. There is just nothing like that for conventional bioretention systems at all in this country, at least. Hence why we see, for me, that's a key reason why we see such consistent pollution load removal rates, whether it's Australia or overseas.
Yeah, and it's really
Yeah.
that's really comes down to when you look really closely at the data, you see that the effluent quality coming out of Filterra is typically much lower than normal bioretention.
Mm,
It's because we control every component that goes in.
mm,
We don't just mix it with a bucket and a loader and just hope for the best. The individual components are all checked, double checked, and triple checked in various quantities and batches and sizes in different orders from the manufacturers, put all together to see the variance in each material going into it before we even blend. And then we spend 3 to 6 months putting the optimal blend together. And then we actually go out and batch it. And we batch it in sort of one process for, a period of 3 or 4 months. So no one does. There's no bioretention media that's made to specifications, nor the QA or QC checking that you ever see. So that's why we can get, 20 times the flow rate. That's why we're sometimes a fifth of the size of conventional. And that's why we get the great effluent quality coming out of the system. It's TN 0.5 milligrams a litre coming out as a concentration basis is ridiculously low for a bioretention system, but it's consistent because we have tight control all the way through. Now, if you don't want to have that tight control, that's fine. Just don't expect to get the same result as we're getting here. So
mm,
it's extremely important to control and understand the difference between QA and QC. I think a lot of people sort of mess that up when they're making media. Hey, we've got a plan, but are we actually checking that, through control that the quality assurance is actually the correct one we should be using for this? So, and then that's just not done anywhere else that we've seen. So we've taken the manufacturing from our filter cartridge and all the QA/QC involved in that. We've moved it across to bioretention with Filterra because there certainly was a gap in the market that we saw.
mm.
Bioretention works great. You just need the controls in place to ensure that it's basically delivered as per its designed and specified.
Yeah, and just from my perspective as well, like looking at the data in more detail, and it's obviously more detail than I can talk to in an hour long webinar, but it seems that you notice here, for example, the load removal rates are a bit higher than the concentration efficiency ratio, which is a concentration reduction metric. So load removals are higher than concentration reductions. And if you look at the data, it's really consistent. Filterra works harder when it needs to. It's a perfect stormwater treatment asset in that regard, in that when flows are high or concentrations are high, the concentration reductions are particularly impressive. Like the effluent concentrations coming out of the systems, particularly in high flow events, are particularly low, which I think's hence I guess that explains why we see higher load removal rates relative to concentration reduction rates.
Yeah, it's extremely consistent as well,
Mm,
regardless of influent concentration and or flow. So, like if you look at the CRE percentage removal, that obviously CRE is I think a poor metric for the number of storms we're looking at. If there was 50 storms, the CRE metric and multiple sites, that'd be great. But the efficiency ratio for the concentrations gives you the real picture, because the anomalies or outliers have a less, I suppose, less pronounced effect on the overall outcome. But then you need to look at also the concentration with ER, but also your load removal. And as Brad said, it's, you know, Filterra's performing, obviously when there's low concentration, slow flow, it's not doing a hell of a lot. But as the load increase or the concentration increases, as the duration of storms go out,
Mm.
Filterra is still providing the same consistent results. That's why you're getting the derivation, or the difference, the delta between sort of the concentration removal and load base removal. And that was picked up by the reviewers,
Mm.
who I think for Squip did a great job,
Mm.
just as a passing comment. But it's these results will vary because they're different metrics, and that's
Mm.
okay.
Mm.
But it was interesting to see where it performed so well.
Mm. Yeah. Cool. Let's keep on trucking. And it's worthwhile noting, like, whilst we're looking at a snippet of time, like I said, what, a 12 or 13-month period, we've got 6 years of data at this one site already, and we're seeing no deterioration in performance. If anything, the Filterra certainly works better after that initial establishment period. And that's actually really consistent with what we've seen from our colleagues in the States from Contech. They looked at, and this is publicly available, I can swing it to you if you like, but they've done some long-term analyses of Filterra's bioretention that have been in the ground for several years. And yeah, similar results, consistently high performance and no reduction in the drainage rate of these systems, which is getting back to the consistency of Filterra bioretention systems. These are the I guess the studies of conventional bioretention systems that I've been able to pull out of the published media environment. And as I've sort of spoken about before in other webinars, the performance of conventional bioretention systems is highly variable. We often see nutrient concentrations in particular increasing across the system, and I feel as though, this is just my hunch, I feel as though a big reason for this is just the variability in the specification of the filter media. Obviously, in the States, they use filter media that's higher in organics, but even within Australia, I feel as though a filter media supply that says it's consistent with the Forbes specs, for example, I think there's a real leap of faith that a data sheet from a stockpile 6 months ago is actually representative of the material that you get delivered to your site, and no one's checking that. And I feel as though
And
without that QA/QC, you're not going to get that consistency.
and how can it be? Like, we're
Mm.
talking, well, organic material. What type of organic material?
Mm.
From what source? Is it the same source? Is it a different
Mm.
supplier? Is part of it recycled? Is it not? What's the percentage we're using? 20, 30, 35%? Like, it's no wonder. Like, stormwater is variable enough. And that's always been the difficulty with
Mm.
stormwater. No two sites the same, no two storms the same. So you're going to get this variability anyway. But throw on top of that the actual, this complete variability within all the ingredients and the sources of that, together with who's mixing it. There's no wonder that the results are sort of, there's a big bandwidth, I suppose, of where the results come in, because there's
Mm.
so much change in the delivery and specification of the technology.
Yeah, and we're not here to bag conventional bioretention systems as well. I just think there's a lot that the proponents of conventional bioretention systems could actually apply from what
Mm.
we do and what others do, whether it's in the States with Contact guys or colleagues in New Zealand who I know are dialing in today. So welcome, everyone. But in terms of the verification, don't take my word for it. It's all publicly available on that website you can see here. So on that website, the Storm Australia SQIDEP website, there is the verification certificate for Filterra bioretention, but also the reviewer's report. And the two independent reviewers that Storm Australia employed were Mark Liebman from Sustainability Workshop and Ricky Kwan from ACOM. And yeah, like I agree with Michael. Is that it's a lot to get your head around, and I'll talk to that in a sec. But I think they did a really good job. But in terms of the modelling, the verification certificate basically specifies how you should be modelling it in music, and the fundamental recommendation for that verification certificate is to use the bioretention node, but adjust the filter media properties to be consistent with this table 2 values here. So as people who have used music before and modeled bioretention systems, you can adjust filter media properties, and there's certain recommendations around, say, sandy loam or conventional bioretention systems. Basically, you use the same procedure as in using a bioretention node in music, but you adjust key parameters. And the key parameters are, in particular, the saturated hydraulic conductivity, which we've obviously talked about. It does drain quicker than conventional, but also the TN and ortho P concentrations in the filter media. And the reviewers were very confident in the fact that by using this method is actually provides a good representation of bioretention or filter bioretention systems in the real world. The other thing to consider when it comes to the verification certificate is if there's any limitations. So as per the certificate, basically says, look, Filterra bioretention system, yeah, model it in accordance with bioretention node and table 2 here, but make sure it's designed consistent with the manufacturers, Ocean Protect's recommendations, and also make sure it's maintained appropriately. And this is a key thing I think that gets forgotten about when it comes to the SQIDEP verification certificates. We've been pedantic around these verification certificates. These assets are only only going to perform in a manner consistent with their design intent if they are appropriately maintained, consistent with recommendations. These sort of conditions are consistent for all our SQIDEP verified devices, but I don't see that, at least in most of the other verification certificates. And I think that's a real omission, which I think is important to recognise. But again, this verification certificate's available on the website. And so Filterra bioretention is now our 5th SQIDEP verified device. We've obviously had Ocean Guard, the gully pit insert technology, gone through and got the SQIDEP tick. Stormfilter, both the PSORB technology and the NPSORB technology have both got SQIDEP verification, as has the jellyfish technology. So again, all the verification certificates and reports for those are all on that SQIDEP website.
And I'd say,
yeah,
by most far, the most difficult was Filterra, given that the way it can be modeled. It is bioretention, more or less. And so and that was credit to the reviewers there, because we said, look, the music software manual says we should be modeling it as bioretention. We shouldn't be using the generic node for this. So that was put all the data aside and the field test aside, get past that. Then how do you actually model this in music? And it's the key difference that we had. And I think it's, whilst it took, quite some time to, I think we all came to the consensus with the reviewers at the end was, look, this is the really only appropriate way that we should be modeling this. It's the most appropriate way. So that was, forget everything, all the study and everything like that, and the results, to actually then apply those metrics into a form that can be used, that complies with the software manual, was just the last extra bit on top, which we never encountered with Stormwater or Ocean Guard jellyfish, anything like that.
Yeah, it's a really good point. Actually, a couple of things to note on that. Like, there was actually a lot of comparisons between what music predicts and what we observed on the site. And actually, they provided a really good comparison. And then the reviewers took that further and said, okay, well, if I take this bioretention node and music with the adjusted properties, what does it look like in other parts of, in other climates, for example? And they were, long story short, they were confident that the bioretention node with the adjusted properties provided a reasonable real world representation of Filterra in the real world. I'd love someone to actually do that for conventional bioretention as a side note. I haven't seen that. As I've talked about before, the conventional bio node in music, if you just use it for a conventional system, is based on lab data only. This is the only field verified bioretention modeling method that I have seen to date. I'd love to be proven wrong though. But also, regardless of what music says, and there's obviously a lot of ways you can probably fudge models, etc. Regardless of what music says, there's a little note in here from you can see in table 2 that regardless of what basic music says, these systems need to be sized at least 0.3% of the upstream catchment. And generally, we see across all or the majority of climatic areas and probably development types across Australia, 0.3 Filterra with a filter area sized at 0.3% of the upstream catchment should be sufficient to achieve the typical load-based removal targets. And that's obviously a key benefit for Filterra. Like I said at the start, generally Filterra is 3 to 5 times smaller than conventional bioretention systems. But again, regardless of what music says, they need to be at least 0.3% of the upstream catchment area. In terms of we've talked about modeling a little bit, but look, if you're bamboozled with music modeling, that's all fine. You can just ask Ocean Protect to do your music modeling for you. No obligation. We don't have to. There's no guarantee of a sale or installation. That's fine. That's just the nature of our business. We can give you the SQIDEP verified music nodes and spreadsheet calculators if you like for the storm filters and jellyfishes if you like, or you can just do your own music nodes based on the SQIDEP verification certificates. Which again are publicly available. And if you want, we can check the models if you like, but don't have to if you don't want us to. So long story short, there's a bunch of modeling options, and we're certainly happy to help again at no charge. The SquidUp experience. Michael touched on this at the start. It's been a long process. It's worthwhile noting that there's a lot of work that goes into the SquidUp submission. Obviously, you've got to pay some cash at the front, and you've got to provide a lot of information. And it is a very difficult thing for the reviewers to do. So Mark Liebman and Ricky Kwan, they had a tough job. The detailed performance report alone was something like 180 pages or something, talking about the study, the results, the metrics, etc. And then, in addition to that, we're providing all the supporting information, the individual storm reports, the chain of custody information, lab results, etc., site photos, drawings, maintenance reports. You name it, stat decks, additional peer review reports. There's a lot of information to get through, but fundamentally, I guess one of the key challenges was it just took so long. And not a criticism against the reviewers. I think they did a great job given the task at hand. It certainly took a long time just to get started. We submitted in the Filterra bioretention in March of 2023, and we didn't actually have our first meeting until 13 months later. So it just took a long time to just start. And then obviously there was work involved with getting it verified. But yeah, thankfully it's done now.
Yeah, 13 months for Ocean Protect to get a meeting. It was interesting, but we got there in the end. Once we got it going, now that's no fault of the reviewers, I
Nah.
might note, but once we got it going, we were okay. But yeah, this one was technically heavy, and
Mm,
with Brad with the submission, yeah, it was just there's lots of data.
mm,
We need to be completely transparent and open, and I suppose that's the difference you see with Ocean Protect. We have storm logs, maintenance logs. It's clear how we program it. It's clear what the chain of custody is. Like all these processes, we've been refining since 2005, and I suppose that's why we were successful with monitoring Blacktown City Council's 6 odd bioretention basins in Western Sydney, because we had all the procedures and processes built up and modified for quite some time. And just the amount of data, I think that people don't see. Once you jump into one of these, don't expect any change from $100,000 on a site, and don't expect anything less than sort of 3 or 4 years. If you can do it in less than that, time or money wise, I think there's probably some corners that may have been cut, but that's up to you guys to work out. But yeah, it's very labor intensive and cost intensive as well, and
mm,
it's out in the field. Nothing behaves in the field. You have all sorts of problems, ants, rats, you name it. There's things that just don't like to work with computers in the rain,
mm.
and that's some of the things that you have to deal with that you just don't know.
Cool. What now? Michael's probably best to talk about this, but yeah, look, we're just continuing a whole bunch of R&D activities. I'm not sure actually what we're actually able to disclose, but there is certainly, from my
Not a
perspective,
lot.
there's certainly a bunch happening in the background, and there's going to be a lot of really cool innovations and I guess insights that Ocean Protect will be able to share in the not too distant future at all. So I guess watch this space unless Michael has any other comments.
Look, we've brought Filterra to Australia. We've been heavily involved in media development over the last sort of 8 years, and there will be more innovation around this space, whether it be media in the cartridge filters or whether it be Filterra bioretention media. We're certainly well ahead of anyone else in this space. And in the next 6 months, we'll take another step forward with the release of new and varying technology. So look, watch this space. It's pretty exciting. any good engineers out there, send your resumes to Ocean Protect.
Careful.
Yeah, we're always looking for great talent, and our R&D team, I think,
Mm,
is some of the best on ground internally. There's a lot of experience there,
mm,
and yeah, look, I think it's a great. It's probably the best part of the company to work in. I think it's yeah,
mm.
the guys have a real great time, and you can basically the world's your oyster at Ocean Protect with that sort of stuff. It's a real great niche, and you're certainly at the cutting edge of the science in stormwater monitoring. So it's a great job.
All right, enough of a recruitment drive. We might better move on, Michael. But look, thanks so much. Just a reminder, folks, if you do have any questions, I can see that there's a whole bunch that already come through. Please put them in the Q&A panel. And again, just to reiterate, the slides and recording from today will be available on our website there. But if you do have any CPD requests, please email them to inquiries@oceanprotect.com.au. Obviously, you're welcome to, if you don't get your question answered, or if you've got something you'd like to talk offline about, just reach out to Michael or myself. We're more than happy to talk about whatever you want to talk about. And I might stop sharing and pass it over to my esteemed colleague Daniel Rotto, who's going to help out with the Q&A.
Yep. I guess, yeah, before we get started, there are a few questions that have come through, but giving some others some time to send through their questions. I guess something that I think that I'd be interested to get you guys to talk a little bit more about is we talk about we wanting SQUIDEP to be improved and updated, but what do we want that to actually look like? Because it's easy to say that we want it to be improved, and that could be, I guess, conflicts of interest around us being like, oh, we want it easy for us, but the reality is we want it actually to be harder for us and everyone. But what does that look like, and what does that mean?
Michael, do you want to have a crack?
Wow. Look, on the technical specification side, look, I think sequential storms is very important to reduce or limit the cherry picking that takes place. We shouldn't. Stormwater is highly variable. You're going to get negative results. If you see data sets without it, you wonder why. And that I've done enough monitoring to see that any site will produce negatives. That's just all low removal efficiency. So that's probably a key point. Also about dissolved fractions of nitrogen and things like that, and phosphorus. They're sort of key cheats as well. Look, sites will typically have lower or higher dissolved inorganic nitrogen species as part of their mix of TN. So choosing site, and you can choose. Like people say, oh, how do you choose? Well, you put a manual sample bottle out there and you see what's running off first and foremost before you go and set up the whole site. So you can actually choose sites with lower DIN, which gives you a better TN removal for a conventional technology. So those little things there can make a profound effect, as long as many others. Look, on the governance side, that it's not really too much worry who writes the report. We're not so concerned about that, but that that chain of custody of sampling, that needs to be completely at arm's length. You'd sit there and say to yourself, well, oh, look, it's done by a consultant. Well, hang on. How much is the consultant getting paid by the manufacturer? And I always sit there and say, well, look, and consultants do work for manufacturers all the time, and that's okay. If you're getting a fee of $5,000 or $10,000 from a manufacturer to do a consultancy job, that's okay, because they've probably worked with others. But if you're copying $20,000 or $30,000 on a regular basis per month, say, from a manufacturer, and that would have been racked up, it could be $500,000 to $1 million worth of fees. You've got to ask yourself the question: is that really then independent? If that consultant is actually touching the sample bottles, and you probably say probably not at that point in time. So I think that on that side, that needs to be fixed up as well, because a lot of people wouldn't understand. The layman looking at it wouldn't understand that. At what point in time do you become conflicted? We're all conflicted, and how do we manage that? That's okay, but at what point does that money become so much that the independence is lost? So I think that there's a few things around SQUIDEP that could be fixed up on there, and they're just very broad points, but they need to be fixed up.
I think for me, just timing. Like I know I just don't think Stormwater Australia as a volunteer organisation is appropriately resourced to handle the inquiries that SQUIDEP and the workload that SQUIDEP reviews take. It's a lot of work. So I just think it needs to be a suitably resourced group.
Yeah, and I think that the last thing is the funding model, and I hope I don't get shouted down and killed at the next directors meeting at Ocean Protect, but there needs to be a sustainable funding source for Stormwater Australia. So as much as it pains me to say it, they probably need to be charging a yearly administration fee from some of the major regulators and also the manufacturers to support the program, because without it, the program's too hard to manage in perpetuity. So they need to have some sort of sustainable funding source and work out grandfathering when, versions of SQIDEP change. All
Mm.
these things need to be taken care of. And without that funding coming in every year, well, then it's so much, there's only so much a volunteer can do with their time before they have to pay the bills.
Yeah,
Right.
good response. Moving on to the next question, or first question from someone from Supoon. Treated stormwater should comply with standards prior to use for secondary purposes, although Filterra has shown efficient TSS, TP and TN removal. How about Filterra's performance in pathogen removal?
Do you want to have a go at that, Michael, or I can respond?
I'll give you that one, Brad.
Sure.
We've done
I
limited
know
work on the
we,
pathogens. Yeah,
what's that, sorry?
we've done limited work on the pathogen
Yeah,
removal.
there hasn't been a huge amount of work on pathogens, particularly because I guess the pollutant and load reduction targets aren't focused on pathogens at all. So we're focused on obviously the solids, nutrients, and gross pollutants when it comes to the monitoring side of things. So, but I have seen, and Michael, correct me if I'm wrong, we did do some early pathogen removal analyses on the Filterra, and we did show some reductions. Would it be sufficient to achieve secondary contact recreation standards? I'm not sure. It obviously depends on the influent quality, but I suspect unlikely.
We didn't have enough data to
Mm,
draw any real conclusions. And the
yeah.
data was variable coming out of the system.
Yeah. So again, maybe one of the aspects of future R&D, and it obviously there's over 180 of these systems in the real world now. It's not just up to us to monitor them. People are welcome to their own. That might be an added focus because we fundamentally are seeing stormwater as a more and more suitable and attractive form of non-potable water reuse. So I suspect that'll get more attention in the not too distant future.
On to the next question. What is the cost comparison for this type of application compared to conventional? Could it be cost effective for any 2 to 5 lot subdivisions?
I can have a crack at that, Michael, and you can chime in if you like. Yeah, so cost comparison, we do this actually a lot. So I've got 15 years of putting in bioretention systems. When it comes to designing and modeling them, we're often asked to do a comparison of how big's the Filterra, how big's the conventional bio, for example. Fundamentally, per unit area, Filterra bioretention systems are more expensive. So depending on the size of the system, it can be anywhere between roughly, for the bigger systems, between say $1,200 and $1,500 a square meter. And that includes design, install, and then 12 months worth of maintenance as part of any installation. How that compares to conventional, I still don't generally get a straight answer as to how much a conventional bioretention system costs. And I recognize the costs will vary, but we generally get told somewhere around about $800 to $1,000 a square meter. But so fundamentally cheaper than Filterra, but because these Filterra are 3 to 5 times smaller than conventional, the Filterra bioretention is typically cheaper than the conventional bioretention option. And keep in mind that ignores the potential cost savings associated with land savings. Generally, with Filterra bioretention, for some of the bigger, not so much the 2 and 5 lot subdivisions, for some of the bigger ones, we're definitely can potentially gain a lot for the developer. At the very least, what we're generally seeing is that it's easier to integrate these systems, so less requirement on expensive retaining walls, for example, which obviously saves money as well. Oh, there's another. I think someone's asked the same question.
Similar question.
So yeah, just talking about the comparison between costs for Filterra and conventional bio for capital, but also maintenance costs. But then also how many years does the Filterra need to be replaced? Roughly how many
So
years?
I can comment on that. Michael can chime. You want to chime in, Michael?
Yeah, look, I'll jump just the first bit. This is the direct comparisons, and just probably further to your point, Brad, is that yeah, as Brad said, we're $1,200 to $1,500 a square meter on the capital, but we're 3 to 5 times smaller. So, the square meter rate equivalent to normal bio is sort of $200 to $500 a square meter when we use Filterra. So it's certainly on the cheaper side for Filterra, but than normal bio. But what you're getting is QAQC, supply install, plus also maintenance, plus also the warranty for the 12 months with one contractor, not 5 or 6. So, that's why the outcomes generally are better with Filterra, because Ocean Protect is on the hook. We can't say, oh, sorry, this contractor over here got it wrong. We're on the hook for the whole lot. So that's sort of the difference in cost is not too much. The land take, when land take is valuable, when land take has a monetary value, Filterra becomes extremely popular. And we've seen that from time and time again, even with the smaller scale and the larger scale systems. When that land value is worth something as a physical dollar and cent sense, whether it be more open space, so you can increase the average sale price of your lot, or whether it be you have to carve out more of a forest or something like that, and you have to pay a state fee, Filterra, or you can just simply get more lots back. And the developer can sell those lots. Filterra becomes an extremely attractive proposition that we see. On the replacement side of the mulch, again, on the replacement side of the system, the mulch does a key job in stopping the solids getting through to the filter media. So, it stops the solids, but also gives the moisture for the plants, it cuts the weed growth out, it holds all the gross pollutants on the surface. And typically when a lot of bioretention systems fail, it's surface loading failure that you get. They clog that surface layer and you've got to scrape out those 2 or 3 inches. Well, then, hey, we have to remove the mulch anyway. So we get a lot of it caught in that first layer. And so that's, when does it need to be replaced? Well, it's at this stage, we're not predicting any changes of filter media because we're removing, typically half of the sediment in that first layer anyway, which we remove every 12 months.
Yeah, dollars and cents. I think the other question was around how often do you need to replace the filter media? So we've done a bunch of webinars and presos on this, and if you're keen, it's called "How Long Does My Bioretention Last?" The evidence is overwhelmingly that Filterra and conventional systems, if they are appropriately designed, installed, and maintained, should last in perpetuity. Certainly that's a big if, and it's certainly particularly in relation to maintenance. But we're certainly seeing the systems that have been in the ground for 15 years plus in the US, for example, are still going really well. The oldest systems we've got in Australia is over 6 and 7 years old, still really positive, no signs of slowing down. And the data shows that as well, no deterioration of performance. So fundamentally, apart from after that 12-month establishment period, there shouldn't be any need to essentially engage with Ocean Protect. Happy to help out and maintain these assets, but I'm sure probably someone can probably do it cheaper than what we can, really, if I'm honest. Cool.
Yeah. And final question. During the monitoring period, did you observe mulch floating during large storms? If so, how did you manage this issue?
You're probably more of a local than me, Michael. Is it observed?
Yeah, look, we didn't see, not in this case here. And I think because the way the system was set up, had an external bypass to go the way around. So look, as part of the QAQC, there's 25 steps that Brad mentioned previously. Yeah, there's a few steps that we have to undertake on the mulch. It's about a 90% pass. So theoretically, up to 10% of the mulch can float. So you will see some, especially with the systems that are open body systems, you'll see a little bit of floating. But we always have some protection at the end, whether it be by a pit basket or some sort of stainless steel or mesh screen, just to capture that 10% that may. And the reason is that, that top layer can dry out a little bit, especially when it's on the newer side, the mulch. If you get lots of good rainfall, a bit of sediment in there, it tends to cake and stick together quite well. And that's when you might get up to that sort of, if you don't have that, and then you just get some, and it dries out a little bit, get a long, pronounced dry period, you may get some of that sort of 10% floating. So we have a protection of the outlet to stop that going downstream. But, look, the mulch does a fantastic job. And I think that, there's so many more benefits to having it than not to have it. and it's integral to really the system. And I think that, look, it should be involved on, you know, on any bioretention system. Even just having the 75 mils cuts your weed growth. There's no weed growth at 75 mils. You know, it provides a lot of benefits that we've seen that should be applied across to bioretention. But you can't use softwood, you can't use bark because it floats. It floats a lot more than hardwood. So you need to get hardwood, but the right hardwood. So it's quite dense. So it mats together and it settles and sinks.
It's worthwhile noting it's a very specific mulch, number one. Number two, the risk of mulch movement is certainly mitigated by having these systems offline. If it was a conventional system with a big pipe, try and discharge water over a big area, yeah, mulch should get moved around. Absolutely,
Oh, yeah.
no doubt about that. But there's, again, another advantage of actually keeping these systems offline. And actually, to Michael's point around conventional, like in the new water by design specifications, I think it's called Improving Biology and Bioretention or something like that. It's publicly available. They actually are recommending the application of a mulch, basically, I think, identical to what we use on the surface of conventional systems because of the benefits that we see. We're flush out of time. Hour on the dot. Look, thank you, Daniel, for looking after us with the Q&A. And obviously, if you've got any further questions from today, folks who are still with us, just reach out to Michael and myself. We'd love to talk further. And we'll look to, and I guess finally, thank you for everyone who's dialed in today. Again, we had well over 100, which is amazing because we didn't really advertise this much at all. And thank you to my esteemed colleague, Michael Kenneth Wicks. And hopefully we'll see everyone in person sometime very soon.
Yeah, look, thanks everyone for joining in this year. I think Brad's done a stellar job with these webinars this year. And I think, you know, we've had a lot of people come through, over a couple of thousand people have tuned in sort of, you know, periodically this. And I think Brad's done a fantastic job. So thank you, Brad, and Daniel as well. So thank you guys. And yeah, wish you the best for, you know, a happy festive season.
Cool. See you guys. Enjoy your day. Bye for now.
Thank you.
See ya.